In this video I'm looking at the periodic table. You can see we've got the full title here at the top. It's the periodic table of the elements, and just a reminder for you what an element is: substances containing only one type of atom. The horizontal rows in the periodic table are called periods. So this is period 1 with hydrogen and helium only. Period 2 goes from lithium to neon. Period 3, sodium to argon, and so on. And the vertical columns in the periodic table are called groups. So you can see here the group numbers are actually on this periodic table. So group 1 is this vertical column here, and we're going to speak a little bit more about that in a moment. 2, beryllium down to radium, and then we miss out this chunk of numbers, this middle section, and we get to group 3, which is boron down to thallium, group 4, 5, 6, 7, and the last group on the periodic table, which I'm also going to mention in the video, is group 0. So we'll just do a quick check that that's gone in. So the pen's pointing at an element called germanium. It's element number 32. And all I want you to have a go at is which group and which period is germanium in. And I'm sure you all got that right. Germanium is in group 4, so it's in this vertical column here, and it's in period 4, so it's the 4th horizontal row. Remember, period 1 is hydrogen to helium. Often students forget about this one and they start period 1 there, which isn't right. So in the next little section we'll look at why it's called a periodic table of elements and not just a table of elements. So to help us answer that, we need to know what the word periodic actually means. So its meaning is repeating at regular intervals. So in terms of the elements, what is it that repeats at regular intervals? And this is where we're going to start focusing on a particular group of elements, and we're going to look at group 1. So that's lithium to francium. I'm just going to concentrate on the first 3 elements of group 1, so lithium, sodium and potassium, to make this point. So to make this point, I'm going to look at the reaction between lithium and water. So I've got a little diagram there showing a beaker of water, and we're going to drop a piece of lithium into the beaker of water. So as soon as you drop the lithium in the water, it starts to react with the water, and the first thing you would see would be bubbles of gas coming off. And the gas that's produced in this reaction is hydrogen. Now, provided you added the right amount of lithium to the right amount of water, they would completely react with each other, and once the reaction stopped, obviously there's no more hydrogen being made, the beaker would look like this. So the lithium has actually sort of reacted and dissolved into the water. And you can see the chemical that's made as a result of that is called lithium hydroxide. So there we've got the actual word equation now for this chemical reaction. Lithium plus water makes hydrogen and lithium hydroxide. Now remember, this is not just a table of elements we're talking about in the video, it's a periodic table of elements. Lithium, sodium and potassium are all in the same group in the periodic table, they're all in group 1. So can we work out what sodium and water would make? What would potassium and water make? So if you have a think about that, and then I'll show you the answer. I'm sure you worked it out. Sodium and water would make hydrogen and sodium hydroxide. Potassium and water would make hydrogen and potassium hydroxide. And if I'd chosen all of the other members of group 1, it would have been the same idea. So I'll just throw another reaction at you. So this time we've got the reaction of lithium, sodium and potassium, but this time with oxygen. So without me even going through the answers, let's see if you can work out what you would get. We don't get hydroxide now because there's no hydrogen in this reaction. In the reaction before, the reaction of lithium with water, remember water is H2O, contains hydrogen, and that's why we get hydroxide. So hopefully you can see why we can say what's written in blue now. All elements in the same group have similar chemical properties. And basically what that means is they react in a very similar way. So in the next little section of the video, we're going to look at why this is the case. So to try and get our head around this little section, we need to revisit these numbers that are in the boxes for each element on the periodic table. And in particular, it's the bottom number that we're looking at, the atomic or proton number. So we'll start with lithium. Lithium's proton number is 3. So what that means is lithium has 3 protons. And if you remember, because it's got 3 protons or 3 pluses, it must also have 3 electrons. And if you remember your rules about how the electrons are ordered in the energy levels or shells, 2 electrons in the first shell, then we have to go into the second shell, and we've got 1 electron left, so that lives there. So lithium has the electronic configuration 2, 1. So if you'd like to do the same for sodium and potassium, then I'll go through the answer. So there they are there. Sodium with its 11 electrons has the electronic configuration 2, 8, 1. And potassium with its 19 electrons 2, 8, 8, 1. So hopefully you can see that they've all got something in common. They've all got 1 electron in their outermost energy level or shell. And that's the reason why they're placed in group 1. So the group number actually tells you how many electrons are in the outermost shell. So pick an element, strontium, how many electrons will that have in its outermost shell? Well, it's in group 2, so the answer's 2. Let's go for something a bit more obscure. Antimony, Sb, may never have even heard of this. Well, which group is it in? It's in group 5. It's got 5 electrons in its outer shell. So why do they react the same? Well, it's all because they've got the same number of electrons in that outermost shell. When chemicals react, it's these outermost electrons that actually take part in the reaction. So because these have all got 1 electron in their outer shell, they're going to react in a similar way to each other. And what actually happens in the case of the group 1 elements, you can see I've got these green arrows now. What they do is they actually get rid of this outermost electron, because underneath they've got a nice stable arrangement of electrons. Sometimes it's referred to as a full outer shell, but it's probably better to call it a stable electron arrangement. So if sodium gets rid of that electron there, there's a nice stable electron arrangement in the shell underneath, and same for potassium. So we'll finish by looking at another group on the periodic table. We'll look at group 0, and I'm going to pose this question to you and see if you can work out the answer using the information we've got so far. And the question's there at the top of the board. Why are all the members of group 0 unreactive? And when I go through the answer, I'm just going to focus on the first 3, because that's enough to make the point. Okay, so if you want to think about helium, neon and argon, and then we'll go through the answer. So we'll start with the diagram of the electron shells. So helium has got 2 electrons. They can sit happily in the first shell. So we get a diagram that looks like that. Helium's got an electronic configuration of 2. Neon, 2, 8. Argon, 2, 8, 8. So why would that make them unreactive? Well, if you think about what lithium, sodium and potassium did, they got rid of that outermost electron to get a stable electron arrangement. Well, hopefully you can see that these elements don't even need to do that, because they've already got a stable electron arrangement, and so they don't react. Now, I've already said that the group number tells you how many electrons are in the outermost shell or energy level. One thing I haven't mentioned yet, and we may as well do it now while we've got these diagrams on the board, the period number tells you how many electron shells the atom uses. So helium is in this first row, so this is period 1, it's got 1 shell. Neon is in period 2, 2 shells. And argon, period 3, 3 shells. So the group number tells you how many electrons are in the outermost shell, the period number, how many shells.